Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with number 15 in your Unit 2, homework number 1 for Unit 2. Alright, so there's this object here, and the weight of that object is given. I wrote this in red because that means that most of you will get different numbers there. Mine happens to be the 1400 newtons. Somebody applies this 260 Newton force at 20 degrees as shown, and it says something about this thing's moving at constant speed. All right, so here's a dot for the crate. This thing is moving at constant speed. I'm going to put these dots in to kind of signify that. Now, if there was nothing else going on here, this crate would have to be accelerating, right? But it's not accelerating. That means there's got to be a horizontal force here. Now, hopefully it's obvious what there is. There is a frictional force acting on that object. And frictional forces, and let me back up, it's a sliding frictional force because this thing is moving. Sliding frictional forces are equal to coefficient of sliding friction times the normal force. Right, so this is a material dependence. This will depend on the nature of these surfaces along here. The first thing you're going to need, as is very common when you're dealing with friction, is to find the normal force. So what you need to do is draw a free body of this object. Let me say complete the free body. You need to put the normal force in. Right? I will tell you it acts all along this line, but I'm not going to draw it for you. All right, it acts on this surface right here, but its line of action is along here. There's a gravitational force actually given in the problem. And there's a frictional force. The line of action for the frictional force is right here. It's important that you get that along its correct line of action, and it's important that you get it in its correct direction. Once you get your free body, you're going to write a force equation. Sum of all forces in the y direction is equal to 0, calling this the y direction. Now, you might ask, why that way? Because the normal force, when you put it in this free body, should be vertical, because it has to make a right angle to this surface. So from this equation, you should be able to get the normal force. Now, this object's not accelerating, and that means if you sum up forces in the x direction, also equal to 0. And again, that's important to realize because this is a constant velocity problem. It doesn't matter which way you call right positive, but I'll go ahead and do this. And again, you're going to get that equation from the free body. I will tell you the gravitational force should not be in there, and neither should the normal. Out of this equation, you should be able to get the frictional force. That's a T there. And it should be less than 260 newtons, by the way. I'll even add that. I'll go back and tell you, looking at this picture, the normal you get should be bigger than whatever value you have here, too. Okay, once you have those, okay, you now know your sliding frictional force, you now know your normal force, you can now calculate a coefficient of friction. And again, that's the material dependence. That depends just on the nature of these surfaces here. Right, now, part 2 of the problem. Now we look over here. I believe in this problem it's the same force here, but it's applied now kind of up and right at a 20-degree angle. What you need to do now is complete the free body, put your normal in, and again, it's applied here. That's the contact point. But the line of action for the normal looks like this. Right, so that normal needs to be parallel to that line. Put your frictional force in. Here's the line of action for the frictional force. Now, the first thing is when you're dealing with friction, you're going to need the normal. So the first equation you want to write, sum of all forces, y direction is equal to 0. Let me talk about how I know 0. This force is only 260 newtons. This object weighs 1400 newtons. Now your numbers are likely different, but the fact that this one is so much bigger than this one is probably going to be consistent. So there is no way this force is lifting this thing off the ground. No possible way. So we know it's not going to accelerate up. When you write this force equation, you should be able to get your normal force. You should get a number less than 1400 newtons or less than whatever is here. Then you can write a force equation for the x direction, except now this one is not going to be equal to 0. And the reason is because what we're going to find is that the normal is going to be smaller. Therefore, your frictional force is going to be smaller. And this force's x component is the same as this. So you are now going to have a net force to the right. You should get an acceleration out of this, which will be some numerical value. So anyway, that should hopefully get you by on number 15. Have a great day.